Howdy, this is another video in our series of videos dealing with the textbook First Course in Mathematical Logic by Patrick Suppes and Shirley Hill. We're now concerned with section 1.3, Form of Molecular Sentences. The so-called form of a molecular sentence doesn't depend upon the content, or what's sometimes called the materiality of the atomic sentence or sentences. What does this mean? We're thinking about things in the abstract, in a very, so to speak, formal way. If I say X, and X can stand for any sentence whatsoever, we're thinking in a very abstract sense. We're not thinking about any particular sentence, we're just thinking about all sentences possible. If I say we have the atomic sentence, it is Sunday, or the atomic sentence, it is cold outside, or the atomic sentence, Socrates is a man, and so on and so forth, we have particular content. We have materiality. We can also think about molecular sentences in this very abstract sense, in this formal sense. A conjunction could be thought of as X and Y, a disjunction X or Y, a conditional, a hypothetical, if X then Y, and a complement or negation, not X. Let's say we have the sentence, Socrates will go home, or Socrates will go to the store. So this is a molecular sentence. It's a disjunction because we have this or. We have a material, concrete example. It has content. Socrates will go home, or Socrates will go to the store. And just using our common sense and our understanding of the English language, we can understand what this proposition or this sentence is saying. It's a disjunction. If we think about it in the abstract, we can say, hey, that's just X or Y in the formal sense. So X or Y is the form of this particular concrete material example. Socrates will go home, or Socrates will go to the store. But by the way, the inputted content can be atomic or molecular. It doesn't matter. So strictly speaking, this X here, for example, might be a molecular sentence. Okay, and likewise with this Y. Or it might be atomic. It doesn't matter. Again, we're just thinking about the form of the type of sentence that we call a conjunction, which is an and statement. Likewise with a disjunction, a conditional, or a complement. One of the remarkable things about logic is that we can think about things in this very formal abstract sense. That we can think about a disjunction as X or Y, and then think about what that means without always having to think about concrete examples like Socrates will go home or Socrates will go to the store. Right now, let's try to think about the various sentential connectives and their relation with ordinary English, with ordinary language. For example, we have the disjunction. Words like either, words like or, depending on the context, might represent a disjunction. Moreover, words that are synonymous with either of those two words, again, depending on the context, might represent a disjunction. Another possibility is the word unless. If I say, I will go to the store unless I go to church, this might mean the same thing as I will go to the store or I will go to church. Thus, there are different ways to represent a disjunction. When we're reading an ordinary English sentence, we should keep this in mind. This will help us when we're translating it into mathematical logic, into propositional logic. And then we have a conjunction. Words like both and represent a conjunction. Here there are a ton of possibilities. We have words like furthermore, moreover, also, etc., etc. Other possibilities include yet, additionally, although, and so on and so forth. And then we have the conditional. This is the hypothetical. If X, then Y. But sometimes the then part is missing. It is, so to speak, implicit. We might have if such and such, comma, such and such. Another way to express a conditional is implies, such that P implies Q. This is the same thing as if P then Q. Another possibility is given that P, then Q. And then we have the complement, or the negation. Words like not, non, and the math symbol not equal to are complements. Here the connective is usually found within a sentence. For example, the cat did not eat the mouse. The word not roughly appears in the middle of the sentence. Another possibility is it is not the case that such and such, or it is false that such and such. It's simply important to remember that there are different ways to express the same thing in the English language, or for that matter, in any other language. Moreover, especially in terms of the mathematical logic, it's easy to become so obsessed with the symbols we forget that those symbols should represent something. Hence, we should think about the disjunction in different words. Likewise, we should think about the conjunction in different words, and the conditional in different words, and the complement in different words. This helps to solidify our understanding, and it helps us in terms of translating English sentences to the mathematical propositional logic. Together, let's work on exercise 2, part A, from page 9 of the Suppes and Hill textbook. We're to use parentheses to show the form of the following molecular sentences. Sentence 1 tells us John is here and Mary has left. We have the sentential connective and. This means we have a conjunction, and is certainly therefore a molecular sentence. But within that molecular sentence, we have two atomic sentences. We have John is here, and we have Mary has left. In other words, we might think of this as A and B. That's the general form. For sentence 2, we have if x plus 1 is equal to 10, then x is equal to 9. Clearly, we have a conditional, if then. There are two atomic sentences. The antecedent, the x plus 1 is equal to 10, and the consequent, x is equal to 9. We can think of this as if A, then B. Sentence 3 is a little bit different. We have either Mary is not here or Jane is gone. We have two sentential connectives. We have the not, we have the or. How should we look at this? We have to think about what is dominant. What's the major sentential connective? The hint is the following. It's the first word, actually. The either suggests that overall we have a disjunction. So this not is only applying itself to Mary is here. It might be best to rewrite this a little bit to get to the general form. So we can think of it this way. We can say Mary is here. That's an atomic sentence, but it's being denied, so we'll say not. And we'll put that in brackets. That's a molecular sentence. It's not the case that Mary is here, but that's embedded within an even larger molecular sentence, which is a disjunction. So we'll say or, parentheses, Jane is gone. How about number 4? We have if either x is equal to 1 or y is equal to 2, then z is equal to 3. There are two sentential connectives. We have the if then and we have the or. What's dominant? Well, notice that the either appears after the if. So what's dominant is the conditional. So we can think of it this way. Let's rewrite this a little bit. So if, and we'll put in brackets, parentheses, x is equal to 1, or in parentheses, y is equal to 2, then z is equal to 3. So notice, of course, that what's dominant is the if-then. In the antecedent, we have a disjunction. There are three atomic sentences: x is equal to 1, y is equal to 2, z is equal to 3. And we have two sentential connectors. We have the if-then, we have the or. And what's dominant is the if-then. Sentence 5. If x does not equal 1 and x plus y is equal to 2, then y is equal to 2. There are three sentential connectors. We have the if-then, we have the and, we have the not. What's the dominant sentential connective? It's definitely not the not, because the not is only applying to x is equal to 1. In other words, it is not the case that x equals 1. The and is really part of the antecedent there. So overall, we do have a conditional. So in other words, let's just rewrite this a little bit. We have if, curly bracket, we have this x is equal to 1. That's an atomic sentence, but it's being denied, not. And we'll place that in brackets. And then we have this conjunction, and. Here we have x plus y is equal to 2. And close those curly brackets. Then, and in parentheses, we'll put y is equal to 2. So notice we have this atomic sentence, this atomic sentence, and this atomic sentence. The x equals 1, that atomic sentence is being denied, and is being placed in a conjunctive relationship with x plus y is equal to 2. That's all part of the antecedent to a conditional, and the consequent is the consequent is just y is equal to 2. And that's it. Up next we have section 1.4, symbolizing sentences. I'm the amateur logician. Thank you for watching. I hope these are helpful. Let's continue on with this textbook.